Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be dealing with another 15 set of questions from Series A of ISS Statistics Paper 2026 of Statistics Paper 1. And before starting the topic, I would like you all of the students, those who have given me their comments, their appreciation comments. I am very glad that you find this video very useful. Many of you has been responding to me, and I am very thankful to all of you for giving such an appreciation. And your appreciation makes me to do more and more for all of you. So keep on appreciating me, and we'll be bringing more and more of these kind of videos, which will be helpful for not only the people who have given the exam this time, but also to the ones who are preparing for the future ISS examinations. Okay, after moving forward, let us start with the series A. Again, we'll be taking series A only. We have already done question number 60 to 80 of series A and question number 1 to 30 of series A. These many questions have already been done. Those who haven't seen it yet, they can go and rewatch the previous lecture videos and check your concepts where you are lacking or where you couldn't find the answer. And those who are preparing, they can see what trend has been followed in this year's ISS examination. And moving forward with question number 31 to 45 of series A. Again, we'll be taking it in 3 parts. So let us consider what all parts can be solved just by seeing. So we'll be starting by question number 31 here. First of all, dividing all of these into parts 1, 2 and 3. So question number 31 clearly states that we will be requiring some of the calculation. So let us consider this of part 2. Question number 32 requires also calculation. So let us consider part 3. Question number 33, part 2. Question number 34, part 1. Question number 35, part 2. Question number 36, part 2. Question number 37, part 1. Question number 38, part 2. Question number 39, part 3. Question number 40, part 3. And all of these questions from 41 to 45, we'll do it simultaneously along with themselves, because all of these questions are from numerical analysis part. So we'll be taking them together. We are not dividing right now them in part 1, 2 or 3. Okay. So before this, let us begin with all the questions of part 1. Part 1 questions till now we have only calculated this 34 and 37. First of all, let us see question number 34. So we are taking part 1. Question number 34 states that we have been given the variance of x bar as sigma square by n minus n upon n minus 1, and the factor n minus n upon n minus 1 is ignored. This is ignored. And on what condition is this ignored? The first condition states that it is ignored when n is small, very small, n reaches to 0 and capital N reaches to infinity. When n reaches to 0 and capital N reaches to infinity, then we can see here that it is very much leading to equal to 1. Then this factor, suppose I am taking it as f, then factor reduces to 1. When we place this here, we can see that it reduces to 1. Okay. Now, so equation number 1 is correct. Now moving towards equation number 2. Equation number 2 states that when n is equals to n. If we put n is equals to n here, we will get answer 0. So our factor reduces to 0. So this statement is wrong, that it is ignored. It can only be ignored when this factor is equals to 1. If it is equals to anything else but 1, then it won't be ignored. So if it is 0, it won't be ignored. Now moving towards the third statement, which states that population is infinite. Now population is infinite means capital N is infinity. We have seen this case beforehand. So here finite factor will reduce to 1. So this statement is also correct. Hence statement 1 and 3 are correct. And what they have asked, select the correct answer using the code. 1 and 3 is option number C. 1 and 3. So just by seeing this, because I have to explain you, I am explaining the whole of it. Just by looking at this question, you can solve it. Now moving towards another part of question number 37 of part 1. Question number 37. This was the direct implementation. Question number 37. Kruskal-Wallis test, KW test, is equivalent to ANOVA. This arises only in one case, when all observations are replaced by their ranks. If you have learned non-parametric test, then this was an easy question for all of you, which is option number D. All observation when replaced by their ranks, then Kruskal-Wallis is reduced to ANOVA test. So we have given in our courses, we have provided everything in very detail about the non-parametric test. Those who have taken the course would have been benefited from that and could have solved this question. Now moving towards another question. Let us take the series 2 of this question number 31. We are now moving towards part 2. Question number 31 have given us that normal population pi 1 and pi 2 has mean equal, but standard deviation of pi 2 is twice that of pi 1. So standard deviation of 2 is, let us say it is standard deviation of 1, let us say it is equals to sigma. Then standard deviation of 2, second population, is 2 sigma. It is twice that of 1. And n has been provided to us as 2000. Now from each population, the difference of sample means in all probability. First of all, we have to calculate the difference in means. So mu1 is equals to mu2. So the difference in means would be equal to 0 because they are both equal. Now we have to find the difference in population. We have to find the difference in standard deviation. To find the difference in standard deviation, which means the means x1 bar minus x2 bar, then it has the formula of sigma 1 square upon n plus sigma 2 square upon n. Now here sigma 1 square is sigma square and sigma 2 square is 4 sigma square upon n is nothing but 2000. So we can write this as 5 sigma square by 2000, or simply we can write it as sigma square by 400. Now this is the standard, this is the variance of this difference. Now if we have to calculate standard error of this difference, then it would have the formula standard error is equals to under root of this variance, which is under root of sigma square by 400, which is nothing but sigma by 20. 1 upon 20 is nothing but 0.05, so it can be written as 0.05 sigma. Now it is clear that it is either less than 0.05 or greater than 0.05. But one more thing is there. Whenever we are taking limits, whenever we have to calculate the probability, the maximum probability is at 99.73%. which is a 3 sigma limit. The maximum probability that we have to calculate, the main thing here is in all probability they have asked. The maximum probability in all probability is 99.73, which is 3 sigma limit. Now if 3 sigma limit we have to take, then we have to multiply the value of standard error by 3. So it will be 3 into 0.05, which is 0.15. This is our 3 sigma limit. Okay. So it has the formula x1 bar minus x2 bar should be less than 0.05, or it lies within the limit of 0.05. If it lies within the limit of 0.05, so it should be less than 0.05, which is our option number B, less than 0.05. Okay, I hope that this question is clear with all of you. It just included some of the concepts of your normal distribution and then it was solved. Now moving towards second question of our question number, let us take 33, second one. Question number 33, sorry. A normal population has mean. So they have given us mean is equals to 0.1 and standard deviation is equals to 2.1. N is equals to 900 has been given to us. And we have to find the probability that x bar is less than 0. First of all, we have to convert this x bar into z, standard normal weighted. To convert it, we will be calculating the probability as x bar minus mu upon sigma by root n. So I am putting it directly here, x bar minus mu, which is 0.1, upon sigma, which is 2.1, upon root n, which is 30, which is nothing but equal to probability that z is less than minus 0.1 upon 0.07. Okay. This reduces to probability of z is less than minus 1.43. On dividing, we will be getting the ratio minus 1.43. For calculating this probability, if you have done the normal distribution very nicely, then this is nothing but very easy for you. It is nothing but 0.5 minus probability of z lies between 1.43 and 0. This is nothing but this. And probability that z lies between 1.43 and 0 is 0.4236. This is nothing but 0.0764, which is our option number A, which is correct. Now I can show you the how to calculate this probability if you are new to this. How to calculate this probability. Suppose we have been provided with a normal distribution. This is our normal distribution. This is our central line, which is mu, which is 1.1, and this is our line, which is x bar. X bar here is nothing but equal to 0. Okay, they have provided us this, and we have to calculate the value of minus 1.43. So probability that z is less than minus 1.43, this is the probability that we are talking about, right, which is less than 1.43. And the half distribution, suppose this is the half region. This whole region has the probability of 0.5 and this whole half on the left side has the probability of 0.5. To get this out of this whole half, we have to minus this from the half. So that is what we have done here, and that is how we have got our probability of standard normal distribution. This is very important concept and very crucial concept for this for our statistics point of view. Now moving towards another part of question number 2. Let us see which part. Okay, let us consider this question number 35. Question number 35 included, we have been given a population with sample size 5 and normal population with mean 2.5 and variance is equals to 36. This has been provided to us, and they have given us the probability that the sample variance lies between, uh, we have to calculate that the probability that sample variance lies between 27 and 45. This is the question that they have asked. First of all, let us see the formula. So n minus 1 s square upon sigma square follows chi-square distribution. This we did yesterday also. This follows chi-square distribution with n minus 1 degrees of freedom. In the previous lecture also, we did exactly the same question. Here also exactly the same question has been asked, but the numerical is asked. There was direct result was asked, which means the chi-square n minus 1 was asked. So this is the formula. So we can also say that it is nothing but n minus 1, which is 4s square upon sigma square, which is 36, is equals to chi square. We can write it like this. So chi square will be equal to s square by 9 if we cut 4 and 36. So this is the relation that we have got. Now we have to convert this probability into chi square probability. First of all, we have to put the values here. So if we put the value of s square as 27, if s square is equals to 27, then chi square becomes 27 upon 9, which is 3. And if s square is equals to 45, then chi square becomes 45 upon 9, which is 5. So our probability converts to probability that chi square lies between 3 and 5 is equals to probability that chi square is less than equal to 5 minus probability that chi square is less than equal to 3. But they have given you the greater than equal to 3. So we will do 1 minus that. So here we can write probability x is less than equal to chi square 5, 0.71270 minus 1 minus probability of chi square greater than equal to 3. Equal to can be put because it is a continuous distribution, so equal to doesn't matter. 0.71270 minus 1 plus 0. What they have given, 55783. Now on adding and subtracting this question, you will be getting your final answer as 0.27053, which is your option number C, the correct answer. So this is how we calculate the conversion of one distribution to another, and it was also an easy question. Now moving towards another question, this question 36. Let us take this into consideration. If we talk about question number 36, then this is nothing but T statistics. So we have been given that T is equals to 3, and we have taken another given a sample if the sample variance is double. So the value of T statistic is x bar minus mu upon sigma by root n. Now older sigma square, suppose older was sigma, then the new sigma is twice of the old sigma, right? Variance is the new twice of the new old one. Let us take it like this. The variance of old one was sigma, and the variance of old one was sigma square, and variance of new one is new t. I am writing it new and old. Now new t is 2 times of the old one. They have put it here, variance is double. Then the new t statistics become. So we have to put it in new t statistics. Tn is equals to x bar minus mu upon sigma. Sigma here is root 2 sigma upon root n, right? So we can put it like this, 1 upon root 2 into x bar minus mu upon sigma by root n. This is old one only, the formula for old one. Okay, and this is the formula for new one. Now, if you can see that this is nothing but the formula for the old T statistics. So we can write T old, and the T old has the value given as 3. So the T new has the value as T by root 3 by root 2, which is our option number C, which is the correct answer for question number 36. This was as easy as this. So moving forward to another question. Question number 38. I hope that you can see the questions on the screen. If there is any discrepancy in seeing the question or anything like that, you can comment us. We will be solving your issues. Question number 38 says that x follows uniform distribution with 0 and 1 as the limits. And we have to calculate probability that x1 is greater than x. Now, first of all, let us see that we have a ordered statistics x1, x2, and so on till xn, right? And if we have to calculate the probability that x1, which is the first and the smallest digit, smallest number in all the ordered statistics, if x1 is greater than x, then all of the others are bigger than x1, so they will be also be greater than x. So we can write it as that probability that x1 is greater than x into probability that x2 is greater than x into probability likewise xn is greater than x. Now, since x follows uniform distribution, so probability that x is less than equal to x is nothing but 1 minus x. X. Probability that x is less than equal to x, since x follows uniform distribution. So probability that x is less than equal to x is x, and probability that x is greater than x is nothing but 1 minus x. Now we will be just substituting the values here. Now on substituting the values here, okay, we are substituting the values here. This will be 1 minus x into 1 minus x into 1 minus x up till n times. So we can write it as 1 minus x up till n times. So this is our option number B, which is the correct answer. This was your question number 38. If you know the concept of uniform distribution and this probability one, then it was an easy topic. Now moving towards our next question of the series, which is question number 40. Now we are beginning with the last series, which is part 3. Let us begin it with 40 only. We are only left with 3 questions. So 40 says that we have been given a sequence. The sequence given to us is 1 into n square, 2 into n minus 1 square, 3 into n minus 2 square, and so on till n into 1 square. Now if we see that the rth term, let us see the rth term. It is r into n minus r plus 1 whole square. You can clearly see this, that this is the rth term, r into n minus 1 whole square. Now can we open this? We can open this by n plus 1 minus r whole square. Opening this, we will be getting n plus 1 whole square plus r whole square minus 2r n plus 1. And multiplying r inside, we will be getting r n plus 1 whole square plus r cube minus 2r square n plus 1. Okay. Now we have got the Rth term. What have they asked in exam? What is the mean of the numbers? So to calculate the mean of the number, first of all we have to calculate the sum of our terms and divided by the last term, the number of terms, which is n. This is the value of mean. So to calculate this, first of all we have to calculate the sum of r terms, so which is r goes from 1 to n tr. If we sum over r, so it will be n plus 1 will get outside, summation r goes from 1 to n r plus summation r goes from 1 to n r cube minus 2n plus 1 summation r goes from 1 to n r square. This is your sum value. Now we all know that the values of sum here can be written as n plus 1 whole square. Sum over r is r, sorry, n plus 1 upon 2. Sum of first natural number is n plus 1 upon 2 plus sum of the cube of n natural numbers is n square, n plus 1 whole square upon 4, and the sum of the square of natural numbers is n 2n plus 1 3 n plus 1 upon 6. This is the final. So this is our summation. R goes from 1 to n tr. Now on solving this, we will be getting our sum as n plus 1, 2n plus 1 upon 12, n plus 1 whole square. Okay, this is our summation over r goes from 1 to n tr. Now if we divide it by 1 upon n, if we divide it by n, so this n will diminish from the here, and we are only left with this. So this is the mean, this is the mean of all the r terms, or this is the mean of all the terms of this sequence, and hence our option number A is the correct option for this question. I hope that it is clear. It was a tricky one, but it was easier. If you know the trick, then it was easier. Then moving on towards our next question in the series, which is question number 39. Question number 39 states that we have been given a sample of odd size n from a uniform population, then the mean and variance of distribution of median are respectively. Suppose we have been given x1, x2 up till xn, and n is equals to odd. So we can write it as n is equals to m plus 1 for simplification if we want to calculate, and all xi follows uniform distribution with the limits 0 and 1. This has already been given to us. Okay, first of all this. Now if we have to calculate, sorry, n is equals to 2m plus 1, where m is any digit, any number. So if we have to put it into odd numbers, then m is any digit, and the sum can be represented as 2m plus 1. If it would have been even, then the sum would be 2 into m. That's how we represent the sum. Now if we have to calculate the sample median, so sample median, let us say sample median is nothing but kth order statistics. Sample median is this. So if we are talking about kth order statistics, then k is equals to m plus 1. And if we put it here, then if we have to find the value in terms of n, then it will be n plus 1 upon 2. So the value of k here can easily be determined as n plus 1 upon 2. So the mean of sample median will be equal, now clearly if xi follows This is a rule that if xi follows uniform distribution with limits 0 and 1, then the kth ordered statistics, which is xk, will follow beta distribution, beta 1 distribution with the limits alpha and beta. Okay, now for calculating mean, first of all we have to calculate the values of alpha and beta. Alpha is nothing but equal to k, which is n plus 1 upon 2, and beta is nothing but equal to n minus k plus 1, which is equals to n plus 1 upon 2. These are the values of alpha and beta for kth order statistics or following uniform distribution. Now we just have to calculate the mean and variance of this. So the formula for mean is alpha upon alpha plus beta, and the formula for variance is alpha beta upon alpha plus beta into alpha plus beta plus 1 whole square. Now on solving and putting the values of alpha beta here, we will get the value of mean as half, and we will get the value of variance as 1 upon 4n plus 8. You can solve that on your own. I am not solving and creating it a big conclusion. You can solve it on your own, and hence these are the part of question option number B. Hence option number B is the correct answer. So this was a difficult question because it included so many concepts and many of you wouldn't have known the concept. So it will be considered under difficult ones. Now we'll be moving towards the last part of part series 3, which is this question, question number 32. Question number 32 says that mean height of 15 male students who showed above average participation in college athletics was 68.2 inches. So we will be considering it in group A above and group B below. So mean N1 is 50, mu1 is 68.2, and the standard deviation of 1 is 2.5 inches. While 50 male student who showed no interest is 50, mu2 67.5, and sigma 2 is equals to 2.8 inches. This has already been provided to us. We have to find the observed difference in the mean height to be significant at 5% level. The sample of each group has to be increased by. If we have to find the observed difference in the mean height should be at 5% level of significance, then we have to find the critical value, and the sample size of each group has to be increased by what percent should be by what number should we increase the sample size in order to get our final answer. So for calculating this, first of all we have to calculate the current difference in mean. The current difference in mean is mu1 minus mu2, which is 68.2 minus 67.5, which is 0.7. This is your final current difference in mean. And the current difference in standard deviation is equal to, current standard deviation, standard error, is nothing but equal to under root of sigma 1 square n plus sigma 2 square n2 is equals to, if we put it here, then it will be 2.5 square plus 2.8 square upon 50. Both of them are 50, so we will be putting it like this. So it will be equal to nothing but 0.53. You can calculate it by your own, and I am directly writing the answer. It is 0.53. So we have calculated current difference in mean and current standard error. Now required standard error that we require is standard error is 0.7 upon standard error of mu should be equal to 0.53. This is the property that they have given to us. Sorry, it should be 5% significant, so it is 1.645. At 5% level of significance, the value of z is 1.645. So if we divide it by the new standard error, then this should be this much significance. So from this, the new standard error we calculate it as 0.17 upon 1.645, which is nothing but equal to 0.4225. You can calculate it by your own. Okay. Now required standard error we have calculated. Now we have to calculate required size of n. To required size of n, we have to put the value. We have to put the formula of standard error here. Standard error has the formula under root of sigma 1 square plus sigma 2 square, and n is equal in both the cases. So I am writing it. So n standard error we have to we have already calculated. Now we have to just put the values of here 2.5 whole square plus 2.8 whole square, and n we have to calculate. So I am putting n here. And by solving all of this, we will be getting our value of n as equal to 78. So n will almost be equal to 78. Now what have they asked? How much should it be increased? Originally n was given as 50-50 but both, and now n has got 78 bigger. So now n should be n new minus n old. So n new is 78 minus n old is 50. So it should be at least increased by 28 to get it significant at 5% level of the significance. So our option number C is the correct answer. We should increase it at least by 28 to get the difference in mean 5% significant at significant at 5% level of significance. Okay, this is how we solve this question. Now all the parts have been completed by us. Now we'll be moving towards the numerical analysis part. So first of all, we'll be taking this question number 41, which is on the screen. Question 41. This is a very easy question. So they have given us delta of log fx. If we have to calculate delta of log fx, it is nothing but fx plus 1 log of x plus 1 minus log of fx. And we can also write it as log of fx plus 1 upon fx. So this is equation 1. Now the one that is equal to this equation, we can also find it like that. Now we can term it like log fx plus 1 plus fx minus fx upon fx. I can write it like this, right? Now we can expand it like log of fx plus fx plus, let us put it equal to h minus fx upon fx and upon fx. We have put it like this. Okay. Now we can put it like log fx get cancelled, it is 1 plus fx plus h minus fx is delta of fx upon fx. Now this exactly matches with our option number C, and hence our option number C is the correct answer for this question. Now moving towards our question number 42. Many of you would have tried to solve it like let us take the cubic polynomial ax cube plus bx square plus cx plus d, and that would have entangled you in the examination. So the quickest way to solve this kind of question in the examination is, we first of all we make the difference table. So this here we will take x, here we will take fx, delta fx, delta square fx, delta cube fx. Let us take it till delta cube. If any other difference will come, we'll take it that much. 0, 1, 2, 3. 1, 0, 1, 10. Now the difference of 1, 0 and 1 will be minus 1, 1 and 9. It will be 2, 8. It will be 6. Any other difference cannot be made, so we will be taking till here only. Now to calculate any function, suppose we have to calculate fx, then it will be f naught plus xc1 delta f naught plus xc2 delta square f naught, and so on. Likewise, right? You all know the formula. Now just putting the values here and solving it. If we put the values here and solve it, it will be f4 is equals to f0. f0 has the value 1 plus 4c1 at delta f1 f naught is minus 1 plus 4c2 delta square f naught is 2 plus 4c3 delta cube f naught is 6. And you can solve after solving this question, your final answer will be 33, which is our option number B in this question. You can solve this all on your own. You all know how to solve them. I'm not wasting time in calculation. You can solve it by your own and by your method of calculation. That would be easier for you as well as for me. Okay, so this was your question number 42. Moving towards another question of this series, which is question number 43. Now there two statements have been given to us. The first statement states that n plus 1 dividend difference of a polynomial of n at degree are 0, where n is a natural number. Yes, this statement is true, and we have very much in detail done this, and it is also one of the PYQs of your ISS examination. So statement 1 is true, that n plus 1th dividend difference of a polynomial of n degree is 0. Now if we consider statement 2 here, statement 2 says that nth dividend difference for a polynomial of degree n can be expressed as the quotient of two determinants each of order n. Now the only change that should be made is the determinant should be of order n plus 1 order. The only thing that they have missed out here is n. This should have been n plus 1. So hence this statement is wrong. This is the correct one and this is the wrong one. And hence only one statement is correct, which is option number A is the correct option. One only is the correct option. Okay. Now moving towards another question, which is question number 44, and it required more time to calculation because we have to calculate the dividend difference. So the lowest possible degree of polynomial px using the dividend difference. First of all, to calculate the possible degrees, they have given us 5 data values, and from that then we have to calculate the dividend difference. So first of all, we will be putting the values of x, then fx, and then we'll be calculating dividend differences. 7, 10, 11, 4, 5, 7, 10, 11, 13, and the values against them is 48, 100, 294, 900, 1210, 2028. Now the formula for dividend difference. First dividend difference is we have to minus 100 minus 48 upon 5 minus 4. So it will be 52 by 1, which is only 1. 294 minus 100 upon 7 minus 5, which is 194 by 2, which is 97. And so on, you can calculate for all of them. Now again, if you have to calculate delta square fx, then it will be 97 minus 52 upon, now the terms 7 and 4 will be included, so 7 minus 4, suppose it is coming as x. Now we have to calculate delta cube fx. Till delta cube only you will be getting the values as 0, 0 and 0. So how much, what is the degree, possible degree of polynomial? It is 3, because the third degree, the third difference is equal to 0. So our option number A, which is 3, is correct. You can do it on your own and check the final answer. I have provided you the final answer. The last one, which is the third degree polynomial or the third dividend difference, will be equal to 0. And whenever the nth dividend difference comes equal to 0, that is your first order. That is your order. Now moving towards our last question for today, which is question number 45. If the interval of difference is h, then what is the value of? So they have given us delta square upon e into e raised to the power x into e raised to the power x upon delta square e. First of all, let us take them individually. If I am taking them individually, so delta square upon e. Delta is nothing but 1 minus e square, e minus 1 whole square upon e. So putting them in value, e square plus 1 minus 2e upon e. So they can be written as e minus plus e raised to the power minus 1 minus 2. Now putting the value of e raised to the power x. So e into e raised to the power x plus e raised to the power minus 1 e raised to the power x minus 2 e raised to the power x. Here e raised to the power x is e raised to the power x plus h plus e raised to the power x minus h minus 2 e raised to the power x. Now this can be, we can take e raised to the power x common from here, and we will be left with e raised to the power h plus e raised to the power minus h minus 2. Okay, so this is our first term. Now we can solve this again here. This is our second e raised to the power x delta square e raised to the power x. This is the second equation. Now to solve this, we will again take e raised to the power x plus h e and denominator delta square into e raised to the power x. Delta square is nothing but e minus 1 square. So we are putting it equal to e minus 1 whole square e raised to the power x. Just expanding it, e raised to the power x plus h upon e square e raised to the power x plus e raised to the power x minus 2 into e raised to the power x. Now on opening it, it will be e raised to the power x plus h upon e raised to the power x plus 2h plus e raised to the power x minus 2 e raised to the power x plus h. Here also we can take x common, so it will be e raised to the power x plus h upon e raised to the power x common e raised to the power 2h minus 2 e raised to the power h plus 1. Now here we can clearly see that This is the square term, so we can take it as e raised to the power x plus h, x and x. This we can write it as e raised to the power x into e raised to the power h. X and x get cancelled, so e raised to the power h upon a square plus b square minus 2ab. So e raised to the power h minus 1 whole square. We can write it like this. And here also, if we take e raised to the power h common from here as well, e raised to the power x plus h, then we are left with e raised to the power h minus 1 whole square as common. So numerator and denominator we have got. Now we can find the final answer. So our final answer will be the combination of 1 into 2. So one states that e raised to the power x minus h into e raised to the power h minus 1 whole square into e raised to the power h upon e raised to the power h minus 1 whole square. This whole get cancelled with this whole, and we are left with e raised to the power x minus h plus h. Minus and plus h also get cancelled, and we are only left with e raised to the power x, which is our option number D in this case. You could have also solved it by like this. You could have solved it by like this: delta square e raised to the power x. Here I have written it wrong. It is e raised to the power x. Delta square e raised to the power x, delta square e raised to the power x get cancelled, and 1 upon e into e raised to the power x. This also get cancelled. So we are only left with e raised to the power x. But that always doesn't conclude in every question. So we have to solve it in detail to get the final answer. So I hope that this is clear. Option number D is your correct answer, which is e raised to the power x. This was your part 3 or part 4 of this series, and I hope that it is clear with all of you. We have done series A. It might differ, the number of question number might differ in series B, C and D. You can see it likewise, and wherever you feel any doubt, and at whatever point you think that this class is lacking or anything is lacking, then you can contact us or you can write your comment in description. And many of you have been sharing your thoughts and comments with us, which is highly appreciable. I would like many more of you to comment down below and give us a handful of appreciation. Your appreciation is very valuable for us in working towards the future and bringing more of the free lecture videos on YouTube. All the best. Thank you.